All right, keeping it going with number 9, we have the limit as x approaches 2 of x over 4 minus x squared. So if you plug in 2, what do you get? We get 2 over 0. So this tells us there's a vertical asymptote. So the question is, are we going to positive infinity or negative infinity as we approach from the left and the right? So what we should do is we should think about 1.9 versus 2.1. Because this is like approaching the limit from the left-hand side, and this is approaching the limit from the right-hand side. So if we plug in 1.9, we're going to get 1.9 over 4 minus 1.9 squared. So take a second to think about this. Is this going to be positive or negative? Because what we're going to get is we're going to get 1.9 over 0-ish, something close to 0. And it's important to know whether it's positive or negative. So since this is smaller than 2, when we do 4 minus 1.9 squared, it's going to be a positive number that's close to 0. So that's going to go to positive infinity. If we plug in 2.1, 4 minus 2.1 squared is going to be 2.1 over 0, and it's going to be negative because this is bigger than 2. So 2.1 squared is bigger than 4. So if we divide by a negative number close to 0, that's negative infinity. So we say this limit does not exist. Limit as x approaches negative infinity of 2x plus 3 over 1 minus x squared. If you were to do L'Hopital's rule here, you would get the limit as x approaches infinity of 2 over negative 2x, which is going to approach 0. But you can also recognize that this is just the horizontal asymptote. So the degree on top here is 1 versus the degree on bottom is 2. If there's a bigger degree on bottom than on top, then the HA is just 0. So this limit is going to approach 0. Again, review your horizontal asymptote rules. Okay, this one is asked, it's a multiple choice asking what is the horizontal asymptote of this function. So we should look for the degree. It's a degree 2 over a degree 2. Okay, double check to make sure none of these exponents are bigger. Yeah, so it's degree 2 over degree 2. So at infinity, and this is the justification for this, at infinity, you can basically disregard these pieces because infinity squared is so much bigger than these pieces that they basically don't matter. So at infinity, we're treating this as 6x squared over 2x squared, which means at infinity, this is going to cancel to 3. So y equals 3 is our horizontal asymptote in this case, so that is answer D. Okay, last limit as x approaches 3 from the right is what this means, from the right-hand side. So that basically means plug in a number close to 3 that is slightly bigger than 3. So what is that going to give us? 6.1, 3.1 plus 3 is 6.1, over 3.1 minus 3, right? And that's going to be 6.1 over 0.1. So this is, this is a little bit different than how I approached it before. I'm actually showing you what this value is. And if I plugged in 3.01, that would be 3.01 plus 3 over 3.01 minus 3, which is 6.01 over 0.01. So this is what I mean when I say positive 0. When I say positive 0, I'm saying a number that is really close to 0, but that's also positive. So if we take 6.01 and divide it by a positive number, the result is going to be positive. And if we take 6.01 and divide it by a number close to 0, that result is going to be bigger and bigger and bigger. So this limit is equal to infinity.